This is Sravanthi, Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about topics surface coatings, hard dipping, metal cladding, cementation, electroplating, electroless platings. So, what is surface coatings? So, surface coatings are generally used to protect the metal from corrosion and also use it for decoration purpose. So, when we applied coatings on base metal, it acts as a physical barrier. So, when we applied these coatings on base metal, it acts as a physical barrier between coated metal surface and environment. So the surface coatings are mainly applied on base metal. Base metal means which we can protect it from corrosion. So when we apply this coating, it protects the metal from corrosion and it is also used for decoration purpose. So these are called surface coatings. So in this mainly we discussed about metallic coatings. So what is the meaning of metallic coatings? Generally these metallic coatings or surface coatings made up of noble metals. Noble metals. Noble metals means here generally silver, iron, platinum. Here in this case applied noble metals or surface coatings made up of noble metals means which are having corrosion resistance on base metal. So that means base metal doesn't undergo corrosion when we apply this type of noble metals. So surface coating is made up of noble metals or known as metallic coatings. So these metallic coatings mostly applied on iron or steel surfaces. These metallic coatings mostly applied on iron or steel surfaces because they are cheap and commonly used construction materials. So that's why you prefer this iron and steel surfaces or steel materials are used as here base metal. That means which we can protect it from corrosion. So we applied the surface coatings or noble metals or that means metallic coatings on this iron or steel surfaces because they are cheap and commonly used construction materials. So now we'll discuss methods of applications of metallic coatings. So in this case, we'll discuss about this hard dipping, metal cladding, cementation, electroplating and electroless plating. So these are the metallic coatings. So now we'll discuss hard dipping. So what is meaning of hard dipping? So hard dipping in this process, generally we applied low melting metals on base metal. Low melting metal on base metal. And the base metals generally they are having high melting points and easily undergoes corrosion. So when we apply low melting metals on base metal, this process is called hard dipping. So in this case, first this base metal, it is cleaned with acid like dilute HCl or H2SO4. So when we treat it with this acid, it removes any impurities present on this base metal. Next, it is the base metal after cleaning this with a dilute HCl or H2SO4 dipped in this coating metal or coating bath. And this bath is covered with flux. This flux is mainly used for prevents from oxidation. So that means it prevents from corrosion. So after some time, the coating metal formed on base metal surface. So this process is called hard dipping. So in this hard dipping method, we apply generally low melting metals on base metal. So such type of metals, say for example, zinc, tin, lead, aluminium. These are the coating metals. That means these are having low melting points than base metal. So generally used base metals are here iron or steel because these are generally commonly used construction material and less cost it is available. So most widely used hard dipping process are galvanizing, tinning. So galvanizing means zinc coating on base metal. So zinc coating on base metal is called galvanizing. So in this case base metal, for example here we are taking iron or steel, pipe or wire or in the form of anything. So iron or steel article first cleaned with dilute acid like HCl or H2SO4. So in this case, it removes any impurities present on the base metal surface. It can be removed by this process. So first of all, what is meaning of galvanizing? Zinc coating on base metal is called galvanizing. Here base metal means which we can protect it from corrosion. So generally in this type of coatings applied on this iron or steel material. So for example here iron material or iron or steel article. First cleaned with dilute H2SO4. So in this case we can remove any impurities present on this base metal surface. Next, this iron metal, after treating this dilute H2SO4 or after removing this impurities, next it is dipped in molten zinc bath. Molten zinc bath, and here maintaining temperature range is 425 to 450 degrees centigrade temperature. And this coating bath is covered with ammonium chloride flux. So this flux is mainly used for prevents from further oxidation. Next, this iron piece is taken out and coated with a thin layer of zinc. So next, excess of zinc is removed when we pass it through the pair of rollers. And finally, it is annealed at annealing chamber. Here it maintains temperature range is 450 degrees centigrade temperature. And it's cooled slowly. Finally, you'll get galvanized iron sheet or galvanized steel sheet. This process is called galvanizing. For example, here galvanizing means zinc coating on base metal. So here base metal means generally we are using iron or steel. So base metal, that means which we can protect it from corrosion. Here in this case we are using iron or steel as a base material or base metal. So we applied zinc coating because zinc is having low melting point than iron. So we applied zinc coating on base metal. This process is called galvanizing. First this iron wire or iron sheet. It is dipped in this dilute H2SO4 and here maintaining temperature in 60 to 90 degrees centigrade. So in this case, any impurities present on this base metal, it can be removed. Impurities can remove when we dip it in this acid solution. Next it is cleaned with water. Next dried in this drying chamber. Dried in this drying chamber. Next this is dipped in this under that iron article, dipped in this molten zinc bath, and here maintaining temperature ranges 425 to 430 degrees centigrade temperature, and this molten zinc bath is covered with ammonium chloride flux. Ammonium chloride flux. So after some time that uniform layer formed on this base metal surface. So next excess of zinc is removed when we pass it through this pair of rollers. Pair of rollers. Excess of zinc is removed. So finally we'll go to annealing chamber and slowly cool. After that finally we'll get galvanized iron sheet. So this process is called galvanizing. So this is the process used in this method. First cleaned with acid solution and cleaned with the water, dried in drying chamber, and after that dipped in this coating metal surface, coating bath, and it is covered with ammonium chloride flux and hard air. Then finally pass it through the pair of rollers. Finally you'll get galvanized iron article. So what is the use of galvanizing? It is mainly used to protect the roofing sheets, pipes, wires, screws, etc. in this method. But what is the disadvantage of this galvanizing? It is toxic. That galvanized utensils we cannot use it for storing or preparing for food items because zinc dissolved in dilute acids. So it forms highly toxic compounds. So this is the main drawback of galvanizing. Galvanizing utensils we cannot use it for storing food materials because it is dissolved in this dilute acids to form highly toxic substance. So that's why galvanized utensils we cannot use for storing food materials. It is the main disadvantage of galvanizing. But it is used for protection of roofing sheets, pipes, wires, screws, nuts, etc. So some of the examples of galvanized iron articles, nuts or bolts after coating this. So this coating is mainly used for protection of this iron metal or iron nuts or bolts from corrosion by applying this zinc coating. Next, tinning. This is also one of the hard dipping method. So your tinning means tin coating on base metal. So tin coating on base metal. So already we know that base metal means here we are taking generally iron or steel. So this metal we can protect it from corrosion. That purpose we applied these coatings. So here tin coating applied on base metal is called tinning. So in this case also same, iron or steel article first cleaned with acid solution like it's dilute HCl or H2SO4. So in this case, it remove any oxide film, that means any impurities present on this article. It can be removed when treated with acid solution. Next, this clean iron sheet or iron wire dipped in this molten tin bath. Molten tin bath. And it is covered with zinc chloride flux. It is covered with zinc chloride flux. So this flux already we discussed just now. Flux is used for to remove any impurities or it prevents from oxidation. So when we dip it in this tin bath, it is tin coating formed on this base metal surface and this flux is used for prevents from oxidation. And after that it is passed through the palm oil chamber. So this palm oil also used for prevents from oxidation. That means it prevents from, doesn't undergo corrosion. Metal protects from corrosion. So next pass it through the pair of rollers. Finally you'll get tin coated utensils, iron or steel article. So this tinning of mild steel plates, it is done mostly for the requirement of the foodstuff industry. So in this case it forms 0.022 mm thickness of tin coating formed on this base metal surface. This process is called tinning. The tin coating on base metal is called tinning. So you see here in this diagram, first iron article or iron wire, this is here used as a base metal. We can protect it from corrosion. So this iron article first dipped in this dilute acid like H2SO4 or HCl. So in this case it removes impurities. Next it is passed through the molten tin bath. It is a coating material. Generally this tin is having low melting points than iron. So when it is passed to this molten tin bath and it is covered with zinc chloride flux. This flux is used for prevents from oxidation and after some time this molten tin, the tin coating formed on this base metal surface, that means iron article. Next it is passed through the palm oil chamber. So this palm oil also prevents, this chamber also prevents from further oxidation. So next passed through the pair of rollers, excess of tin is removed. That means uniform layer is a uniform coating of tin formed on this base metal surface. Finally, you will get tin coated iron sheet or iron article. So tin coating on base metal or iron article, this process is called tinning. It is also one type of hot dipping method. So advantages or uses of tinning. So tin coated utensils are used for storing food material. This is the main advantage. This tin coated utensils we can use it for storing food materials. Food preparation purpose also we can use. But galvanized utensils we cannot use it for storing food material. That is the main difference between galvanizing and tinning. But what is the disadvantages of this tinning method? So tin has negative E0 value than iron. Less negative E0 value. That means it is having high reduction potential than iron. Generally, high reduction potential means that metal acts as cathode, iron acts as anode. So that's why here this is the main disadvantage here. Tin has less negative, the less oxidation potential, that means high reduction potential than iron. So in this case, tin acts as cathode, iron acts as anode. So when we applied this coating, if in case any small crack formed on this layer, so that base metal easily undergoes corrosion. So even a small crack or puncture of coating can lead to intense corrosion. It easily undergoes corrosion. This is the main disadvantage of the tinning process. But this material, this tin coated utensils, we can use it for storing food materials or foodstuffs. Now let's discuss metal cladding. So metal cladding, in this case, in this process, sandwiching the base metal, which we can protect it from corrosion. So the base metal is sandwiched between two corrosion resistant metal. So base metal and coating material sheets, all these three are arranged in sandwiched formation. Then pass it through the pair of rollers. So this process is called metal cladding. So base metal and coating material sheets, all these three arranged in sandwiched form. That means base metal arranged in between two corrosion resistance metal, and which we can apply on this base metal. So this base metal arranged in between two corrosion resistant metals, all these three arranged in sandwich form, then pass it through the pair of rollers. So this process is called metal cladding. So first this base metal is placed in between two sheets of coating metal, and pass through the pair of rollers. So under the action of heat and pressure is called metal cladding. For example, here see, best example is aluminium clad. So in this case, base metal is duraluminium. Base metal is duraluminium. Example, aluminium cladding. So in this case, base metal which we can protect it from corrosion, that is the duraluminium. It is a base metal, and corrosion resistance metals are aluminium. So this coating material sheets and duraluminium base metal, that means duraluminium sheet arranged in between two corrosion resistance metal, that is the aluminium in this process. So all these three arranged in sandwich form and pass it through this pair of rollers. So finally we'll get aluminium coated duraluminium. So this is called metal cladding. So see here, examples, aluminium clad, just will discuss a plate of duraluminium, it is the base metal. So it is sandwiched in between two layers of pure aluminium. So this is called aluminium cladding. It is under, that means duraluminium and pure aluminium sheets pass through the pair of rollers. Finally we'll get metal cladding, that means aluminium cladding sheets. So in this case, to improve its strength and corrosion resistance. And this aluminium cladding sheets mainly used in aircraft industry. This aluminium cladding sheets mainly used in aircraft industry. So one more example is copper clad steel. Generally it is used in electrical industry. Because it has good strength, good electrical conductivity. So here copper coating on this base metal is called copper cladding, and it is used in mainly electrical industry. So in this metal cladding, any cladding type method, a base metal sandwiched between two coating resistance metals and pass it through the pair of rollers. This process is called metal cladding. Best example, aluminium cladding and copper cladding. Aluminium cladding mainly used in this aircraft industry, but copper cladding used in this electrical industry. Next, third metallic coating method is cementation. So cementation is the diffusion of coating metal on the base metal. So in this case, the coating metal for diffuses all over the base metal surface is called cementation. So that means base metal, same first cleaned with acid solution to remove impurities and next heated with coating powder. So during heating process, this powder spread on this all over this metal surface. So it is called cementation. So see here, the base metal is heated with powder coating metal. So in this case, coating metal diffuses all over the base metal surface. This process is called cementation. So there are three types of cementation methods are there: shadizing, chromizing, colorizing. So shadizing means coating metal is zinc. That means base metal is heated with zinc powder or zinc. So in this case, this zinc diffuses on base metal. So zinc coating on this base metal or zinc is heated with base metal. This process is called shadizing. And next chromizing, when coating metal is chromium. So chromizing means coating metal is chromium. That means base metal is heated with this chromium. So chromium coating metal diffuses all over this base metal surface. So this process is called chromizing. Next, colorizing. So colorizing means in this case coating metal is aluminium. So base metal heated with aluminium powder, this aluminium spread on this surface, base metal surface. So simply we say cementation means diffuses coating metal on base metal when during heating process is called cementation. So there are three types of cementation methods: shadizing, chromizing, colorizing. So simply we say shadizing means coating metal is zinc, and chromizing means chromium coating on base metal, and colorizing aluminium coating on base metal is called cementation methods. Next, advantage or use of this cementation process. So these coatings obtained are uniform in thickness. So in this during heating with this coating metal powder, it diffuses all over this base metal surface. It forms uniform layer on this base metal surface. And here steel obtained after shadizing or zinc coating is used as nuts in the form of nuts, bolts, etc. Next, chromized steel and the chromium coating on base metal. It is used to protect gas turbine blades. It is used to protect gas turbine blades. This coating is mainly useful for this purpose. And last one is colorized steeling and aluminium coating on base metal. During heating process, aluminium powder spread on this base metal. So colorized steel is used for making furnace parts. These are the main uses of this cementation process. Next, fourth one, electroplating. So applied coating metal on base metal by passing electricity through the electrolyte solution is called electroplating. So all these coatings are applied these coating materials on base metal, but in this electroplating means we passing electricity through this electrolyte solution. So that's why this method is called electroplating. The coating metal deposited on base metal by passing electricity through this electrolyte solution. Here electrolyte solution means it containing soluble salt of coating metal. It containing soluble salt of coating metal. So this process is called electroplating. So what is the principle involved in this electroplating? So first here in this process, anode is the coating metal. That means which coating we applied on base metal. So that coating metal acts as anode. For example, we applied copper coating. So copper electrode acts as anode. So cathode is the base metal. So base metal means which we can protect it from corrosion. The metal to be protected. So that metal acts as cathode. And electrolyte is soluble salt of coating metal. Soluble salt of coating metal. That means it's present compulsory coating metal ions present in this electrolyte solution. And finally, additives, glue or gelatin used as additives. They are added to the electrolytic solution. So what purpose we add this glue or gelatin? So when we are adding this glue or gelatin additives to electrolyte solution to get strong, smooth deposit on base metal surface. So that's why we are adding this additives to this electrolytic solution. And finally, we'll add brightening agent. So generally these brightening agents, when we are adding this electrolyte solution, it provide brightness to this base metal surface or coatings. So in this case, anode is the coating metal, cathode is the base metal which we can protect it from corrosion, and electrolyte is the soluble salt of coating metal ions. Composite is present in this electrolyte solution. And additives, generally we are using glue or gelatin. For what purpose we are adding these additives in this electrolyte solution? To get strong and smooth deposit formed on this base metal surface. And finally, we'll add brightening agents to this electrolyte solution. It's provide brightness to this on this base metal surface. So during process, on passing direct current, so coating metal ions get deposited on the base metal. So when we passed electricity, this coated metal ions deposited on this base metal surface. For example, electroplating of copper on base metal or copper electroplating. Electroplating of copper on base metal. So here in this case, anode is a coating metal. So here we applied copper coating on base metal. So anode is the pure copper plate, and cathode is the base metal which we can protect it from corrosion, or the metal to be protected from corrosion. That is acts as cathode here. And electrolyte is the compulsory this coating ions present in this electrolyte solution. So in this process we applied copper coating on base metal. So compulsory in this electrolyte solution is present coating metal ion, that means copper ions present in this electrolyte solution. So that's why you are taking copper sulfate solution used as a electrolyte solution. So anode is the pure copper plate and cathode is the base metal, the metal to be protected, and electrolyte is the copper sulfate solution. Here this is the copper plate acts as anode, and this is the electrolyte. Copper, like electrolyte means here we are using copper sulfate solution. So copper metal ions present, coated metal ions present in this electrolyte solution, and this is the base metal object. We can protect it from corrosion. We applied copper coating on this base metal surface. So during this process, first this metal object, base metal, it is cleaned with dilute acid like HCl or H2SO4. So in this case, we can remove impurities. Any impurities present on this base metal surface, it can be removed when we treat it with acids like dilute HCl or H2SO4. So we can remove impurities when we treat it with these acids. Next, it is dipped in this copper sulfate electrolyte solution. So here copper sulfate solution is taken as a electrolyte. And if this cleaned object is now when we treat it with acid solution, so we can remove impurities. Now this cleaned object acts as a cathode, and pure copper plate acts as anode. So during process, when the current is passed from the battery, through this electrolyte solution, current passes from the battery through this electrolyte solution. So in this case, during this process, copper dissolves in the electrolyte. And deposited uniformly on the metal object. Uniform layer formed on this metal object. For example here, so pure copper plate acts as anode. This is a basic metal which is protected from corrosion. So we applied copper coating on this object that acts as cathode. And these two are different, kept in this electrolyte solution. Here I used copper sulfate as the electrolyte solution. So during process, we passed electricity from the battery to this electrolyte solution. So in this case, copper metal ions dissolve in this electrolyte solution. And next we go to the cathodic area, that means this copper metal ions deposited at cathodic area, that means uniform copper uniform layer formed on this base metal object. So what are the reactions takes place here? So at anode, so pure copper plate acts as anode. So during this process, copper undergoes oxidation, then gives copper metal ions and loss of 2 electrons. So at cathode, so when we pass electricity from the battery to this electrolyte solution, copper metal ions dissolves in this electrolyte solution. Next, the dissolved copper metal ions gain of 2 electrons at cathodic area, and there has deposited copper deposited as on base metal surface. This is called electroplating. When you pass electricity through the electrolyte solution, applied coating metal on base metal. This process is called electroplating. Best example is electroplating of copper on base metal. So now let's discuss applications of electroplatings. So what are the applications of electroplating? So this process is widely used in this automobiles, aircrafts, etc. And also this coatings used for decoration purpose. Mainly used for protection of metal from corrosion and also used for decoration purpose, and these are used mainly in automobiles, aircrafts, etc. And this process is also used for refrigerators, jewelry, radios, cameras, typewriters, umbrellas, watches, etc. So many cases we are using this electroplating. And also used for plating of non-metallic materials, also we apply this type of coatings. For example here, gold plated watch and copper plated mug, silver plated teapot. Some of the examples given here this by using this electroplating on this metal objects or base metal objects. Now let's discuss last method of metallic coatings, electroless plating. Electroless plating. So in this process, deposited noble metals. Noble metals means here meaning which is having corrosion resistance than base metal. So that is called noble metals. So applied noble metals on the base metal. Applied noble metals on the base metal by using suitable reducing agent. Applying noble metals on base metal by using suitable reducing agent. So in this case, without using any electricity, that's why this method is called electroless plating. Without using any electricity is called electroless plating. So in this process, we apply noble metals on base metal by using, main thing is here reducing agent, by adding suitable reducing agent, but without using any electricity. This process is called electroless plating. So what is the principle involved in this method? So in this case, when we are adding suitable reducing agent to this coating metal bath, so this reducing agent reduces coating metal which gets deposited on the base metal. So what is the role of reducing agent? Here main role is reducing agent. So when we are adding reducing agent to this coating metal bath, so this reducing agent reduces coating metal ions or coating metals and which gets deposited on the base metal. So here, what is the reaction involved in this? Coating metal ions. So when we are adding reducing agent to this coating metal bath, so this reducing agent reduces the coating metal ions and it deposited on base metal object. So what is the reaction takes place? Here coating metal ions and plus reducing agent, it gives coating metal and oxidized product. This is the principle involved in this. For example, electroless nickel plating. Electroless nickel plating. So in this case, it's involved total 3 steps. Step 1, pre-treatment of activation of surface of base metal. That means any object, that means base metal, we can metal to be protected from corrosion. So that is first we can pre-treatment of activation surface of base metal. We can activate the surface. That means we can remove all the impurities present on this base metal. So how can we remove these impurities? When we treated with acid like HCl or H2SO4. So we can remove all the impurities means activating this surface of base metal. This is a first step, pre-treatment and activation of surface of base metal. For example, here steel is treated with hot dilute H2SO4. So when we treat it with this acid, it can remove all the impurity. That means activate the surface. Now it is acts as cathode. That base metal acts as cathode. Next step 2, bath composition, the preparation of coating bath. So in this case, generally in any coating bath preparation purpose, we are using coating solution, reducing agent, complexing agent and buffer, and we are maintaining certain temperature and pH range. So here we are taking example is electroless nickel plating. So how can you prepare this coating bath, nickel coating bath? So in this case, coating solution is a nickel chloride used as a coating material because it is a electroless nickel coating. That means we applied nickel coating on base metal. So how can you prepare this coating bath? So coating metal is the nickel chloride. Coating metal is the nickel chloride. And reducing agent is the most important reducing agent because reducing agent only reduces the coating metal ions and get deposited on the base metal. So here we are using reducing agent is sodium hypophosphate. Sodium hypophosphate used as a reducing agent in this electroless nickel plating. Sodium hypophosphate used as a reducing agent in this electroless nickel plating. And complexing agent is sodium succinate. Sodium succinate used as a complexing agent. And buffer, generally we are using buffer for maintains the pH, maintain stable pH range. That purpose we are using buffer solution. So here we are using buffer solution is sodium acetate. Sodium acetate used as a buffer solution maintaining stable pH range. So in this coating purpose we are maintaining pH ranges 4.5 and temperature is 93 degrees centigrade temperature. So this is the preparation of coating bath. So first step is pre-treatment of or activation of surface of base metal. So that purpose base metal is treated with acid solution. We can remove any impurities present on this surface. So in this case, for example, steel article or any object, when we treat it with dilute HCl or H2SO4, we can remove any impurities present on this. So now it is active surface or active base metal acts as cathode. Next step 2 is the bath preparation, coating bath preparation. So in this coating bath preparation purpose, generally in this we are adding coating solution or coating metal and reducing agent and complexing agent and buffer solution also. So in this, for example, electroless nickel plating, we applied nickel coating material. So coating material is the nickel chloride and reducing agent is the sodium hypophosphate. Sodium hypophosphate and complexing agent is the sodium succinate. Sodium succinate and buffer is sodium acetate and maintaining temperature range is 93 degrees centigrade and pH is 4.5. So this is the electroless nickel plating. This is the coating bath. This is a base metal object. So when we put in this coating bath, this coating, nickel coating formed on this metal surface and reducing agent reduces the coating metal ions and deposited here nickel coating on this base metal. So this is the principle involved in this. So metal ions, when we are adding reducing agent reduces the metal ions and then form metal deposited on base metal surface, the oxidized product. This is the principle involved in this electroless nickel plating. So third step is the procedure. So these following reactions takes place when the base metal is dipping in this coating bath or plating bath. So what are the reactions takes place here? So at anode, H2PO2 That means hypophosphate. Reacts with water, then form dihydrogen phosphate and 2H plus and loss of 2 electrons. Because at anodic area only oxidation reactions takes place, so loss of electrons. Oxidation means loss of electrons. So hypophosphate undergoes oxidation, then gives dihydrogen phosphate. Next, at cathodic area, reduction reactions takes place. Here reduction means gain of electrons. So here nickel plus 2 nickel ions, because it is electroless nickel plating. So at cathodic area, nickel coating metal ions, a gain of 2 electrons and deposited nickel metal on base metal. So this is the third step. So in this electroless nickel plating, total it's involved 3 steps. So applying coating metal on base metal by adding suitable reducing agent. And in this process, most important is without using any electricity. So that's why this process is called electroless nickel plating. Electroless plating. Best example is electroless nickel plating. And it's involved total 3 steps. Step 1 is preparation of active surface of base metal, well treated with acid. And second one is preparation of coating bath. And third one is procedure. So where it oxidation reactions takes place and how to form this coating metal on base metal. So these are the steps involved in this electroless plating. We'll discuss applications. So this method is used to coat jewelry or perfume bottles, etc. And also this nickel coated polymers used in this decoration purpose also. These nickel coated polymers are used in this decoration works. So all these surface coatings are finally used for protection of metal from corrosion. That means these coatings acts as a physical barrier between base metal and environment. Coating material and environment, and also used for decoration purpose also. So the surface coating mainly in this we'll discuss already discussed metallic coatings. Metallic coating means applied noble metals on base metal, and in this metallic coatings we discussed hard dipping, metal cladding, cementation, electroplating and electroless plating. So all these coatings are used for protect the metals from corrosion and also used for decoration purpose. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.